Assalamualaikum dan selamat petang. Ya. Okay, as you know, we have not finished the syllabus yet. Yeah. So in this video, I will continue our lesson so that we can finish our syllabus. Okay, I proceed to 7.3 application of factors that affect the rate of reaction in life. The smaller the particle size, the larger the surface area for reaction to occur, rate of reaction increases and the reaction is completed in shorter time. Okay, saya lebih suka kamu guna tambah perkataan total surface area. Jangan tinggal perkataan total. So, the smaller the particle size, the larger the total surface area of reactant for reaction to occur. So, rate of reaction increases and the reaction is completed in shorter time. Ini saya tambah sikit lah. The larger the total surface area of reactant for reaction to occur. So rate of reaction increases and the reaction is completed in a shorter time. So for example, in our daily life, what is the application of the knowledge? The smaller the particle size, the higher the rate of reaction. Why is that? Because the reactant will have the larger the total surface area. So what is the application? Apa kegunaan dia dalam kehidupan harian kita? So you see, mince meat cook faster. Maksudnya daging kisar masak lebih cepat. Tahu tak daging kisar? Maksudnya daging yang dipotong-potong lah. Yang daging potong-potong kecil, dia lebih cepat untuk masak berbanding daging yang besar. Alright. And then, smaller pieces of charcoal burns faster and complete to give a hotter flame. Ini pun second application. So, if you have charcoal ni arang ya. Arang ni, mana yang lebih cepat terbakar? Arang yang kecil-kecil lebih cepat terbakar. Okay. Antacid tablet is chewed before swallowing. Tahu tak antacid tablet ni? Antacid tablet ni adalah tablet untuk pesakit yang mengalami penyakit gastrik. Apa penyakit gastrik? Maksudnya orang yang mempunyai terlalu banyak asid hidroklorik dalam perut dia. Jadi orang itu dikatakan mengalami penyakit gastric disease. So orang yang mempunyai gastric disease ni terlalu banyak asid dalam perut dia ya. Bila terlalu banyak asid dalam perut dia, kita akan bagi dia ubat antacid. Antacid ni. Jadi antacid ni need to be chewed before swallowing. Kenapa antacid ni perlu dikunyah sebelum ditelan? Why? Because small pieces of tablet react faster with acid in the stomach. Sebab apa? Sepihan kecil pil lebih cepat untuk bertindak balas dengan acid ya dalam perut. That's why. Alright. Potato strips cook faster. Jalur kentang masak lebih cepat. So, sebab dia lebih kecil jadi dia akan masak lebih cepat. Okay. The second one, we have learned that the higher the concentration, the larger the number of reactant per unit volume. So more reaction can take place per unit time. So rate of reaction increases. We have learned the second one. The higher the concentration, the higher the rate of reaction, isn't it? Why is that? Why when the concentration higher, rate of reaction higher? Why? Because when we use higher concentration, the larger the number of reactant per unit volume. Semakin banyak, semakin tinggi bilangan bahan tindak balas per unit isi padu. So more reaction can take place per unit time. So rate of reaction increases. So for example, acid rain speeds up corrosion or rusting of iron. Okay, acid rain ni tahu acid rain maksudnya hujan asid. Hujan asid. Kamu tahu tak macam mana hujan asid terhasil? Terhasil apabila um, okay, terhasil apabila sulfur dioxide in the air, okay, dissolve in the rainwater. So it will become acid rain. So kamu bayangkan sulfur dioxide, kalau kita punya persekitaran ni terlalu banyak uh, pencemaran udara ya, seperti sulfur dioxide. So that sulfur dioxide will dissolve in the rain. When the rain going down, the sulfur dioxide will be dissolved in the rain and become acid rain. So that acid rain speeds up corrosion or rusting of iron. Ingat lagi tak pasal rusting karat tu? So karat itu dia boleh berlaku apabila ada air, ada oksigen. Okay, ada air dan oksigen ya. Dia berlaku apabila ada air dan oksigen. Jadi acid rain ni dia akan mempercepatkan proses pengaratan ya. Kalau air ni kalau kita biarkan, dia akan terdedah kepada air dan juga oksigen. Tapi acid rain ini dia akan mempercepatkan tindak balas. Sebab apa? Acid rain ini mempunyai kepadatan asid yang lebih tinggi ya, daripada air hujan biasa. Air hujan biasa tu kalau air hujan tu kalau udara kita bersih, maknanya katanya acid rain itu kurang lah. Kalau udara kita kotor, tercemar, so acid rain itu lebih banyak. Jadi dia akan mempercepatkan pengaratan ya. Rusting ni pengaratan. Okay, baik. And then the second one, taking 2 tablets of antacid is more effective to neutralize the acid in stomach. Jadi kalau kamu ambil 2 pil antacid, lebih berkesan untuk menetralkan asid dalam perut. Ini berbanding kalau kamu gunakan satu saja pil antacid ni ya. Sebab kalau kamu gunakan 2 tablet of antacid, so you will have the higher the concentration of the dosage ya, mempunyai kamu akan absorb lebih banyak kepekatan dos ubat itu tadi. Okay, the third one, fanning, burning charcoal speeds up the combustion process. Kalau kamu kipas arang, dia akan mempercepatkan proses pembakaran. Okay, sebab apa? Sebab bila kamu kipas arang tu, okay, kamu akan memberikan lebih banyak kepekatan oksigen. Kamu akan menambah. You will increase the concentration of oxygen to the fire. So the fire will burn faster. Okay. Undiluted bleach solution is more effective to remove dirty stains. So kalau kamu ada bleach ni biasa kita gunakan untuk lunturkan sesuatu ya. Larutan peluntur bleach. Biasanya contohnya kalau kamu ada baju yang terlalu kotor, kamu sental-sental, masuk dalam mesin basuh tak hilang-hilang juga, kamu boleh guna bleach. Bleach ni akan lunturkan. Dia peluntur. Dia bukan hanya menghilangkan kotoran ya. Dia menghilangkan juga warna pada pakaian kamu tu. Jadi bleach ni kena hati-hati. Kalau dia bukan setakat, dia memang efektif untuk bersihkan kotoran, tetapi dalam masa sama dia juga boleh melunturkan warna pada kita punya pakaian. Okay. The higher the temperature, the higher the energy of reactant per unit volume. So more reaction can take place per unit time. So rate of reaction increases. If you still remember, the higher the temperature, the higher the rate of reaction. What is that? When the temperature is higher, so the energy of reactant per unit volume become higher. Semakin banyak, semakin tinggi tenaga bahan tindak balas per unit volume. So more reaction can take place per unit time. So rate of reaction increases. So what is the application of this? So food in a pressure cooker cook faster due to higher temperature. So kalau kamu masak gunakan periuk tekanan, pressure cooker, dia akan cook faster. What is that? Because the pressure cooker has higher temperature, yeah, compared to ordinary cooker. And then keeping food at low temperature in a refrigerator slows the growth of microorganisms. The third one, cookies baked at higher temperature cook faster. And then the fourth one, washing clothes in hot water removes stain much faster. This is the application of this knowledge. The higher the temperature, the higher the rate of reaction. And then we have learned about catalyst. Still remember catalyst? Catalyst can increase the rate of reaction. Yeah? So a catalyst is a chemical that is added to a reaction to increase the rate of reaction for the reaction to be completed in a shorter time. So the application of this knowledge, we have a Haber process. In industry, we have a Haber process. The name of process is Haber process. So in Haber process, we use to make ammonia. Yeah. In this Haber process, we use iron as a catalyst. Dalam proses Haber ni, kita gunakan untuk hasilkan amonia sebenarnya, untuk buat amonia. Jadi dalam proses untuk hasilkan amonia tu, kita akan gunakan iron sebagai catalyst. And then we have Oswald process to make nitric acid. Okay, Oswald process use platinum as catalyst. We have contact process to make sulfuric acid. So contact process use vanadium 5 oxide as a catalyst. And then hydrogenation process to make margarine use nickel catalyst. Catalytic converter is used to reduce pollution from vehicle exhaust gases. Use platinum catalyst. Alright. I proceed to the collision theory. According to the kinetic theory of matter, matter is made up of tiny and discrete particles. Ni kamu dah belajar daripada menengah rendah ya. Okay, pasal matter ni, kinetic theory of matter. Matter is made up of tiny and discrete particles. The particles in matter are in constant motion and constantly colliding with one another. Partikel dalam matter ni sentiasa bergerak. Yeah. And then constantly colliding with one another. Sentiasa berlanggar antara satu sama lain. During collision, the energy is transferred between the particles. Hence, the kinetic energy of the particles differ and constantly changing. Jadi semasa pelanggaran tu, tenaga akan dipindahkan ya, antara zarah. Jadi tenaga kinetik zarah berbeza dan sentiasa berubah. Bergantung kepada collision yang berlaku. Kalau lebih banyak collision terjadi, maknanya kinetic energy lebih banyak akan dipindahkan. Kinetic energy bertambah. Ya. Kalau lebih sedikit collision berlaku, maka kurang tenaga dipindahkan, maka tenaga kinetik berkurang. Jadi itu konsep dia ya. Kalau lebih banyak collision berlaku, tenaga kinetik bertambah. Kalau semakin kurang collision berlaku, maka tenaga kinetik berkurang. Jadi macam tu je. Okay, according to collision theory, for a reaction to occur, the particles of a reactant need to collide with one another to achieve activation energy. Okay, what is activation energy? The minimum energy required by particles of reactant for reaction to occur. Collide in the correct orientation. A collision that meet the above criteria and cause reaction to occur is known as effective collision. Jadi, ini benda baru ya. Collision theory. Apa collision theory kata? Dia kata particles of reactant need to collide with one another. Okay, partikel dalam reaktan itu, semasa tindak balas, for reaction to occur, semasa untuk tindak balas berlaku, for a reaction to occur, the particles of reactant needs to collide with one another. Okay, saya ulang balik Untuk reaction berlaku, dia mesti memenuhi 3 syarat ni. 1, 2, 3. Yang pertama, untuk tindak balas berlaku, zarah particle of reactant need to collide with one another. Zarah reaktan itu perlu berlanggar antara satu sama lain. Yang kedua, syarat yang kedua, untuk tindak balas berlaku, tindak balas tersebut mestilah mencapai tenaga pengaktifan. The reaction must achieve activation energy. Tindak balas itu mesti mencapai activation energy. What is activation energy? Activation energy is the minimum energy required by particles of reactant for reaction to occur. Dia adalah tenaga minimum yang perlu ada pada zarah bahan tindak balas supaya tindak balas dapat berlaku. Selagi tak mencapai activation energy, maka tindak balas tidak dapat berlaku. Ini syarat yang kedua. Syarat yang ketiga, the particles of reactant need to collide in the correct orientation. So itu maksudnya zarah bahan tindak balas, zarah reactant tu, particle of reactant need to collide in the correct orientation. Dia mesti berlanggar dalam orientasi yang betul. Okay, give example. Let's say I have the reaction of HCl plus NaOH. So what is the product? It should be NaCl plus H2O, isn't it? So if I draw the particles, is like this. H is Cl. Okay. HCl must be correct in the correct orientation with NaOH to form NaCl plus H2O. So it must collide with like this. To form so you see HCl collide with the correct orientation with NaOH will form NaCl and H2O, you see. This is the correct orientation. So let's say I have like this. Let's say HCl collide with incorrect orientation like this. Okay, this is not correct orientation of collision. If the collision occurred, it will not produce product. Yeah, it will not produce product because it is the incorrect orientation of collision. So there is no product, there is no reaction occur. I hope you understand. Huh? So a collision that meets the above criteria and cause reaction to occur is known as effective collision. So if the collision satisfied these three conditions, so we call the collision effective collision and the reaction occurred to form products. Okay, I proceed to the activation energy. What is activation energy? Activation energy is defined as the minimum energy that the reactant particles must have to collide effectively and initiate a reaction. This energy is needed to break the bonds. That's activation energy. It's a minimum energy that the reactant particles must have to collide effectively and initiate a reaction. So the reaction must achieve activation energy so that the reaction can occur. Different reactions have different activation energies. The higher the activation energy, the slower the reaction occurs. Activation energy is represented by the symbol EA. Biasanya kita akan tulis activation energy ni dengan simbol EA. EA. Ni EA. In the energy profile diagram, the activation energy, EA, is the difference in energy between the energy level of reactant and the energy of the peak of the curve in the graph. Okay, this is the energy profile diagram. Energy profile diagram shows the activation energy needed by the reactant so that the reaction can occur. So let's say I have a reactant. So the reactant must achieve the activation energy so that the reaction can occur, so that the products can be formed. So you see, this is a EA, activation energy. Minimum energy required by the reactant so that reaction can occur to produce product. Okay, if you still remember in Form 3, the reaction has two types. One is an exothermic reaction. The other one is endothermic reaction. If you still remember, exothermic reaction is the reaction that release heat energy to surroundings. Okay, actually, in chemistry, we will learn this in detail. Actually, in exothermic reaction, total energy of reactant is higher than the total energy of products. So if you draw the energy profile diagram, it will be like this. So you see the energy level of reactant, total energy of reactant is higher than the total energy of product. We can see clearly in the energy profile diagram. But for endothermic reaction, so you see the total energy of reactant is lower than the total energy of products. Like this. Okay. Right now, we want to learn in detail about collision orientation. The reactant particles also need to collide in the correct orientation to produce an effective collision. So, example, reaction between hydrogen gas, H2, and chlorine gas, Cl2, to form hydrogen chloride gas, HCl. So, actually, during a reaction, the particles of reactant need to break a bond like this. Ni nampak ni. Dia perlu memutuskan ikatan. Break the bond to form a new bond here. Okay. So you see, let's say I have a H2 as a reactant and Cl2 as a reactant. So H2 need to break its bond to form new bond with Cl. So you see H will break its bond, Cl2 will break its bond to form new bond as a product. So this is a reactant, this is a product. So actually in the reaction, it involves the bond breaking and bond formation. Bond breaking of what? Bond breaking of reactant, bond breaking of the particle of reactant, and then bond formation of the particle of product. Molecule possess enough energy to overcome activation energy. Molecules collide at the correct orientation. Effective collision, and then reaction occurs. Okay, we still remember about correct orientation. Okay, the particles of reactant need to collide in the correct orientation in order for the reaction to occur. So this is the correct orientation. So you see H will collide H2 will collide with Cl2 in the correct orientation to produce HCl. But if the collision occur in the incorrect orientation, so it's like this. So you see H2 collide in a incorrect orientation with Cl2, the particle will bounce off. So there is no reaction occur, there is no product will be formed. So we see, if we see the condition again, okay, molecule possess enough energy to overcome rotation energy. Yes, but when the molecule collide at incorrect orientation, there is an ineffective collision occur, and then the molecules bounce, no reaction occurs. Effective collision and rate of reaction. For effective collision, it needs three conditions to occur. Collision between particle of reactant, collision achieve EA, and then the particles collide with correct orientation. So the rate of reaction depends on the frequency of effective collision. Jadi kadar tindak balas bergantung kepada frekuensi pelanggaran berkesan, frequency of effective collision. The higher the frequency of effective collision, the higher the rate of reaction. The lower the frequency of effective collision, the lower the rate of reaction. Jadi kalau kamu tengok, semakin tinggi frekuensi of effective collision, maksudnya semakin banyak effective collision ini, maka semakin tinggi kadar tindak balas. Ya. Yeah? Okay. Now, we want to learn in detail about effect of concentration of the rate of reaction. Okay. When the concentration of the reactant increases, the number of particles per unit volume increases. The frequency of collision between particles increases. So the frequency of effective collision between particles increases. So the rate of reaction increases. Okay, this is what happen when we use the higher concentration of reactant. So it will increase the rate of reaction, isn't it? So why is that? Because when concentration of reactant increases, the number of particles per unit volume increases. So the frequency of collision between particles of reactant increases. So the frequency of effective collision between particles increases. So the rate of reaction increases. So it is what happened. Right. Effect of size of reactant on the rate of reaction. When the size of reactant is small, the total surface area of reactant exposed to collision increases. So the frequency of collision between particles increases. The frequency of effective collision between particles increases. The rate of reaction increases. Jadi kalau kita nak jelaskan tentang effect of factors ni to the rate of reaction, mesti sebut benda ni. Mesti sebut semua ni ya. Mesti ada total surface area, mesti ada frequency of collision, mesti cakap pasal frequency of effective collision, mesti cakap tentang rate of reaction increases or decreases. Mesti cakap. Jadi tak kamu akan hilang markah. Alright. Effect of temperature on the rate of reaction. When the temperature increases, the kinetic energy of the reactant particle increases. The frequency of collision between particles increases. More particles able to overcome the activation energy. The frequency of effective collision increases. The rate of reaction increases. Effect of catalyst on the rate of reaction. Okay, when a catalyst is added to a reaction, the catalyst provide an alternative pathway with a lower activation energy for the reaction. More reactant particles able to achieve the lower activation energy. The frequency of effective collision between particles increases. The rate of reaction increases. So I give you example. Let's say I have the energy profile diagram here. This is the exothermic reaction. So you see the use of catalyst will lower the activation energy required for the reactant to produce product. Yeah, you see. Now the EA when we use catalyst is lower. Actually, the catalyst provide alternative pathway with a lower activation energy for the reaction. So more reactant particles able to achieve lower activation energy. So frequency of effective collision between particles increases. So the rate of reaction increases. The same goes to endothermic reaction. When we use the catalyst, you see, it will provide alternative pathway that require lower activation energy. So more reactant particle able to achieve the lower activation energy, so the rate of reaction increases. Exothermic reaction and endothermic reaction, changes in energy can occur during chemical reaction. Reaction that release heat energy to the surrounding are called exothermic reaction. Reaction that absorb heat energy from surrounding are called endothermic reaction. The change in energy content that occurs when reactants are changed into product is named as the heat of reaction and represented by the symbol delta H. So saya rasa kamu tak ada problem ni. Yeah. This is the EA for the exothermic reaction. This is the EA for the endothermic reaction. So the heat of reaction delta H, kita tulis dia dengan delta H ya, is the change in energy content. Change in energy content, change of energy content is a heat of reaction. We symbolize it as delta H. Delta H ni adalah heat of reaction ataupun change in energy content. So for the exothermic reaction, the delta H should be negative. For the endothermic reaction, delta H should be positive. Okay, how do we get delta H? So delta H, kalau saya boleh tuliskan delta H, macam mana kita dapat? The total energy of product minus total energy of reactant. Jadi kamu tengok kat sini, the total energy of product minus total energy of reactant. Okay, that's why we get negative for the exothermic reaction, because you see the total energy of product is lower than the total energy reactant, and vice versa for the endothermic reaction. The total energy of product is higher than the total energy of reactant. Higher value minus lower value, so we will get positive value for the delta H. So we have finished the chapter of rate of reaction. Please do this soalan berformat SPM, objective question, and also the structure question. Thank you. Now we need to proceed to the chapter 8, manufactured substances in industry. First, we need to learn about alloy. Okay, what is alloy? Alloy is a mixture of two or more elements with a certain fixed composition in which the main element is a metal. Actually, alloy ini adalah campuran dua atau lebih unsur mengikut komposisi yang tetap, yang mana unsur utamanya ialah logam. Dia adalah sejenis campuran, mixture of what? Two or more elements with a certain fixed composition in which the main element is a metal. Di mana unsur utamanya adalah metal. Okay, baik. Complete table 8.1 with the name of alloy and importance of alloy. Okay, I give you example of alloy and its importance. Okay, pewter is a alloy. Dah dengar pewter? Pewter is used to make souvenirs. Duralumin, to make the body of an aeroplane. Actually, banyak objek di sekeliling kita ni diperbuat daripada alloy. Dia bukan diperbuat daripada logam tulen, tetapi logam yang telah bercampur dengan unsur yang lain untuk dijadikan alloy. Ya, ada sebab kita gunakan alloy ni untuk buat banyak benda, ada sebab ya. Nanti saya akan terangkan. Okay, I give you an example. Bronze is a alloy to make medals, statues or monuments. Brass to make musical instrument, keys and kitchenwares. Stainless steel to make cutlery and surgical instrument. Steel to make bridges, body of cars and railway tracks. Okay, comparison of properties of alloy and pure metal. Pure metal are made up of same type of atom that is of the same size. In the solid state, pure metal atoms are arranged closely in an orderly arrangement. So if we draw the arrangement of pure metal atom, so you see all of the atoms have the same size, isn't it? Let's say I have a pure zinc. So all of the atom in a pure zinc, all of them consist of atom zinc. So atom zinc have the same size. Atom zinc semua mempunyai size yang sama. So it arranged in an orderly manner. Jadi atom ini disusun dalam susunan yang tersusun secara padat dan teratur. Nampak Arrange closely in orderly arrangement. Okay, properties of pure metal. Kita nak compare sekarang pure metal dengan alloy. Kita tengok dulu properties of pure metal. Pure metal is ductile, maksudnya mulur. The pure metal atoms are of the same size and arranged in an orderly arrangement. As a result, the layer of pure metal atoms can easily slide over one another when force is applied. Therefore, pure metals are ductile or easily pulled into wires. Ductile ni maksudnya kita boleh tarik dia menjadi dawai. Kenapa? Because you see the pure metal atom are of the same size and arranged in orderly arrangement. As a result, the layers of pure metal atom can easily slide over one another when force is applied. Jadi bila kita kenakan daya, okay, the layer of atom slide over one another easily. Dia mudah. Atom ini, layer of atom, dia mudah menggelonsor. Easily slide over one another. Mudah menggelonsor. That's why kita boleh tarik logam tulen ini menjadi dawai. And then, you see, second properties, the pure metal is malleable. Malleable ni maksudnya boleh ditempa. Boleh dibentukkan menjadi benda lain lah. Boleh jadi pedang, ya. Boleh jadi apa-apa sajalah, periuk dan sebagainya. Ya. Okay. Kenapa macam tu? Because you see, there are empty spaces between the atoms in pure metal. Ada ruang kosong antara atom di dalam logam tulen ni. When force is applied, the layer of atom will slide to fill the empty spaces and form a new structure. Therefore, pure metals are malleable or its shape can easily be changed. So you see, apabila force is applied, the layer of atom will slide. Ni bila kita kenakan daya, layer of atom will slide to fill the empty spaces and form a new structure. That's why the pure metal is malleable. Alloy is formed from the mixture of metal atom with metal atom or the mixture of metal atom with a non-metal atom. So alloy ini terbentuk apabila kita campurkan metal ini dengan metal yang lain ataupun metal kita campurkan dengan non-metal. Okay, I give you example. Bronze alloy. Bronze ini adalah sejenis alloy. Kenapa? Sebab kita campurkan copper atom dengan tin atom. Steel alloy, kita campurkan iron atom dengan carbon atom. Membentuk steel alloy. So, the presence of foreign atom that are of different sizes disrupt the orderly arrangement of atom in the pure metal. So, layer of atom in alloy become more difficult to slide over one another when force is applied. Therefore, alloy become harder and stronger than its pure metal. Jadi, bila kita campurkan foreign atom, maksudnya atom asing, atom luar, atom yang lain, ya, dia akan, you see, the different sizes of atom will disrupt the orderly arrangement of atom in a pure metal. Jadi, kehadiran atom asing yang berlainan saiz akan mengganggu susunan atom logam tulen yang teratur. Dia akan ganggu. Jadi, kamu tengok ni susunannya jadi tak teratur lah. Kenapa tak teratur? Sebab size of atom jadi tak sama. Size of atom tak sama. Kenapa tak sama? Sebab kita telah campurkan dengan foreign atom. Kita campurkan dengan foreign atom yang mempunyai size yang tak sama dengan pure metal yang asal. When the arrangement of atom not in orderly arrangement, the layer of atom become more difficult to slide over one another when force is applied. Therefore, alloy become harder and stronger than its pure metal. Okay, if you compare, you see the alloy and pure metal in terms of a surface, alloy is shiny, pure metal is dull. Okay, alloy resistant to corrosion, pure metal is easily corroded. Alloy is hard, but pure metal is less hard. Okay, if we do this experiment to investigate the comparison of properties between alloy and pure metal, okay, problem statement, is an alloy more resistant to corrosion and harder than a pure metal? So we will use this material and apparatus. Okay, resistant to corrosion, the hypothesis, stainless steel is more resistant to corrosion than iron. So variables the manipulated is type of plate, responding is a corrosion of plate, fixed is the size of plate, volume of distilled water. So this is the procedure. We just put the one is the alloy, we use stainless steel, and then the other one is a pure metal, we use the iron plate. Alright, so we put them into the distilled water. So we observe what happened. Okay, this is the condition of metal plate after cleaning with sandpaper. So what happened? The iron shiny and stainless steel all shiny. But after 1 week, we put them into the distilled water. So iron will be rusted and stainless steel still shiny. So, okay, in terms of hardness, bronze is harder than copper. Variables, the manipulated is a type of block. Responding is a diameter of dent on the block. Fixed is a size of steel ball bearing, mass of the weight. Okay, the idea is we will drop the 1 kilogram weight into the steel ball bearing, and then steel ball bearing will produce dent on our alloy and pure metal here. Okay, first we use the copper. We use copper, and then we drop the 1 kilogram weight. We measure the diameters of the dent, and then we repeat the experiment by replacing the bronze block with the copper block. So you see the copper, first we get 4.5, second we get 4.4, and then the third time we repeat, we get 4.3. So the average diameter of dent is 4.4. For bronze, we get 3.2, 3.0, 3.1, 3.1. So hypothesis is accepted. Bronze is harder than copper. Why is that? Because you see it produce smaller diameter of dent compared to a copper. Jadi lekuk yang terhasil pada bronze ini lebih kecil. Kenapa lebih kecil? Sebab bronze ni, alloy, is harder than copper. Copper ni adalah pure metal. Alright, discussion. Why must we use stainless steel plate and iron plate be cleaned with sandpaper? Kenapa kita perlu bersihkan stainless steel plate dengan iron plate dengan kertas pasir? Why? To remove the oxide layer on the plate. What is the difference in the rate of corrosion between stainless steel plate and iron plate? The rate of corrosion of iron plate is higher, because iron plate ni adalah pure metal. So the pure metal has a higher rate of corrosion compared to alloy. Dia lebih mudah untuk terkakis, easily to be corroded compared to the alloy. Which block produces a larger diameter of dent? Copper block. What is the relationship between the average diameter of dent and the hardness of substance? The smaller the average diameter of dent form, the harder the substance. Okay, justify the uses of alloy based on the composition and properties. The uses of alloy is based on the composition and properties of the alloy produced. Iron is converted into steel because steel is harder than iron. Kenapa kita gunakan alloy ni? Sebab alloy ini lebih keras dan juga dia sukar untuk terkakis. It's harder to become corroded. It's harder to undergo corrosion. Dia lebih sukar untuk mengalami kakisan. Yang ini berlaku pada alloy. Alloy ini lebih sukar untuk berlaku kakisan. It's harder for alloy to undergo corrosion. Baik. The uses of alloy is based on the composition and properties of the alloy produced. Iron is converted into steel because steel is harder than iron. Stainless steel is manufactured to prevent steel from rusting. So let's say alloy we use is duralumin. So the composition actually is 93% aluminium, 3% copper, 3% magnesium, 1% manganese. So the properties of duralumin is light and strong, low density, resistant to corrosion. We use to make body of aeroplane, electric cables, bullet trains, racing bicycles. Right? Bronze is 90% copper, 10% stannum. Tin, 10% tin. The properties is strong and hard, resistant to corrosion and shiny. The use is to make statues or monument, medals and swords. Alright. Brass. Brass is 70% copper, 30% zinc. The properties stronger than pure copper, resistant to corrosion, shiny. We used to make musical instrument, kitchenwares. Steel, 98% iron, 2% carbon. It is strong and hard, malleable. We used to make structure of buildings and bridges, body of cars, railway tracks. And then stainless steel. Stainless steel is consists of iron, 73% iron, 1% carbon, 18% chromium, 8% nickel. The properties stronger than pure iron, resistant to corrosion. We used to make cutlery. Cutlery ni pisau, garpu, sudu lah. Surgical instrument, sinks. Pewter consists of 95% tin, 1.5% copper, 3.5% antimony. The properties stronger than pure tin, shiny, does not rust. We used to make souvenirs, trophies and decorative ornaments. Alright, superconductor is an alloy that can conduct electricity or transfer electron without electrical resistance at a very low temperature. The superconductor is applied at the maglev train. Okay, you can search about maglev train. How does it use superconductors to make maglev train? Okay, I proceed to the composition of glass and its uses. The main component of glass is silica and silicon dioxide, SiO2, which obtained from the sand. So basic properties of glass: hard but brittle, chemically inert, transparent, waterproof, heat insulator and electrical insulator. Okay, type of glass. Most of the glasses are produced through the mixing of molten silica with other compounds. If you still remember, right? Glass is made up of silica or silicon dioxide, which obtained from the sand. Jadi daripada sand tu, dalamnya ada silica and silicon dioxide. Jadi silica or silicon dioxide ni kita gunakan untuk buat glass. Jadi mana datang silica atau silicon dioxide ni? Datangnya daripada pasir, sand. Okey. Jadi glass ni dia ada macam-macam jenis. Jadi kita tengok kat sini. We have a fused glass. The composition is silicon dioxide, SiO2. The properties is very high melting point, does not expand or contract much when there is a great change in temperature, transparent. Users used to make spectacles, lenses, telescope lens. So dalam glass, the composition is silicon dioxide, SiO2, sodium carbonate, Na2CO3, calcium carbonate, CaCO3. The properties: low melting point, easily molded, cannot withstand high temperature and can easily crack when subjected to a sudden temperature change. We used to make bottles, glass containers, mirrors, electrical bulb and window glasses. Borosilicate glass consists of silicon dioxide, SiO2, sodium carbonate, Na2CO3, calcium carbonate, CaCO3, aluminium oxide, Al2O3, boron oxide, B2O3. The properties: resistant to heat and chemically inert, high melting point, low expansion coefficient, which mean expand and contract a little under sudden temperature change, does not crack easily. We used to make bowls and plates, cookwares, especially laboratory glasswares. Jadi semua kamu tengok alatan kaca di lab, semua diperbuat daripada borosilicate glass. Why? Because these properties here, resistant to heat, chemically inert, high melting point, low expansion coefficient, does not crack easily. Alright, lead crystal glass consists of silicon dioxide, SiO2, sodium carbonate, Na2CO3, lead to oxide, PbO. The properties, it is a high density, high refractive index. We used to make prisms. Prism ni maksudnya kalau kamu dalam fizik dia gunakan segitiga to produce spectrum of light. When the white light pass through the prism, refraction of light will occur. Refraction ni maksudnya pembiasan cahaya akan berlaku. Okay, decorative ornament. Baik, composition of ceramic and its uses. Most ceramic have a composition of metal compounds, non-metal compound or metalloid compound. Metalloid compound ni maksudnya separa logam lah. Separa logam. Okay, example. Aluminium oxide, Al2O3, boron nitride, Bn, silicon carbide, SiC. This is ceramics. Okay, basic properties of ceramic: hard and strong, break easily, chemically inert, heat insulator, high thermal resistance, electrical insulator. Okay, type of ceramic. Ceramic are classified into two groups: traditional ceramic and advanced ceramic. Traditional ceramic are made from clay such as kaolin, Al2O3 to SiO2 to H2O. The shaped clay mixture will be heated at a very high temperature. The main component of traditional ceramic is silicate, that is a compound that contains silicon, oxygen and aluminium. Traditional ceramic are used to make bricks, pottery ni maksudnya tembikar, teapots and crockery. Advanced ceramic are made of inorganic substances such as oxide, carbides and nitrides. Okay, carbides is a compound composed of carbon and metal. Carbides, kita namakan carbides. Nitrides maksudnya dia mempunyai ion N3-, nitrides. Okay, properties of advanced ceramic: hard and strong, high resistant to abrasion. Jadi advanced ceramic ni resistant to abrasion, mempunyai retangan terhadap lelasan. Maksudnya dia susah untuk menjadi licin lah, disebabkan oleh proses lelasan. Susah untuk menjadi licin. Okay, high thermal resistant, more chemically inert, superconductivity properties. Ingat lagi pasal superconductor tadi. It allow the flow of electricity at zero resistance. Maksudnya sangat bagus untuk alihkan elektrik. Superconductivity properties. Ini adalah advanced ceramic. Okay, silicon carbide is an example of advanced ceramic used to make cutting discs due to its hard and strong properties, brake discs due to its can withstand thermal shock and high resistance to heat properties. Okay, ceramic uses application. Several application of the uses of ceramics. Zirconia ceramic is used in dental implants. Alumina ceramic is used to make knee bone, tulang lutut. Yttrium, barium, copper oxide ceramic is used in magnetic resonance imaging, MRI, machines, to make computer microchips, to make porcelain and ornament item, to make plates, bowl and pots, to make construction materials such as tiles, toilet bowl, cement and bricks. Composite materials is important. Composite material are material made from a combination of two or more non-homogeneous substances that are matrix substance and strengthening substance. The matrix substance is to surrounds and binds the strengthening substance together. Components of composite material, matrix and strengthening material have different physical or chemical properties. The composite material form has better properties than its original component. Okay, I give you an example. Type of composite material. Reinforced concrete. Component, steel bars or wire mesh strengthening substance is embedded in concrete matrix substance. Uses to construct buildings, bridges and dams. Fiberglass. It is a composite material. Okay, so the component is a plastic. Plastic is a matrix substance reinforced with glass fibers. Glass fibers is a strengthening substance used to make water tanks, kayak, printed circuit boards, helmet. Optic fiber. The innermost layer is made up of silica glass fibers as a strengthening substance. The second layer is made up of glass or plastic as a matrix substance. The outermost layer is made up of plastic that act as a protective layer, matrix substance. Used in the field of cables, in computer network, medical endoscope, and video camera. Photochromic glass. Silver chloride, AgCl, and copper 1 chloride, CuCl. Okay, CuCl is a strengthening substance are combined into glass or transparent polymer matrix substance used to make camera lenses, optical lenses, car windows, and building windows. Superconductors, yttrium, barium, copper oxide ceramic, YbCO, has superconductivity properties. Used in the field of transportation to make superconductor magnet. Magnet that is used in maglev train. Industrial and research used in nuclear magnetic resonance machine, NMR. Medical use in magnetic resonance imaging machine, MRI. Okay, we continue to comparison and difference in properties of composite material and their original component. Okay, reinforced concrete, the properties of concrete and the steel bars or wire mesh. Properties of concrete, resistant to corrosion, low stretching strength, high compression strength. Properties of steel bar or wire mesh. Wire mesh ni adalah jejaring dawai. Easily corrodes, high stretching strength. Properties of the reinforced concrete, high compression strength, high stretching strength, resistant to corrosion. Okay, fiberglass. The properties of plastic and glass fibers. Properties of plastic, resistant to corrosion and durable, low stretching strength, low heat and electrical conductivity. The properties of fiberglass, high stretching strength, low heat and electrical conductivity. Properties of fiberglass. High stretching strength, resistant to corrosion, durable, heat and electrical insulator. Okay, fiberglass and glass fiber is different things. So you see the properties also different. Okay, optical fiber. The properties of plastic and silica glass fiber. Properties of plastic, high compression strength, flexible. Properties of silica glass fiber, low compression strength, hard but brittle. Properties of optical fiber, high compression strength, flexible. Photochromic glass. The properties of glass and silver chloride. Properties of glass, transparent, does not absorb UV rays, not sensitive to light. Properties of silver chloride, transparent to visible light, absorb UV rays, sensitive to light intensity. So properties of photochromic glass, transparent, absorb UV rays. Absorption of UV rays depends on the light intensity. So for superconductor YBCO, composed of combination of components such as yttrium-3 carbonate, copper-2 carbonate, barium carbonate, and oxygen. Carbonate compound originally has high electrical resistance at room temperature. The YBCO superconductors produced is able to conduct electricity without resistance at very low temperatures, has low power dissipation, operating at a high speed, and has high sensitivity levels. Okay, please remember to submit the folio when the school open. Thank you.